Hello students, welcome to session of worm and worm gear drives. Initially we are aware of spur gear drives and helical drives. Now we'll come across what is worm gear drive. So following photos are of worm gear drives, everyone knows it. Now it transmits power in non-intersecting shafts. With that, important about worm gear is usually it has very high velocity ratio of around 300 is to 1. Second case or second is it has lower efficiency if we compare it with spur gear or helical gear. It is always used as a speed reducer since a drastic change in speed reduction can be obtained with the worm gear. Second case, what important factors are to be understood about worm gear is worm in a worm gear drive that we call it as a screw is always a driving member. Second case is worm wheel, which is a driven member, which we have to remember. Next one about the materials. Usually there are number of or large variety of materials can be used for gear specifically, which are somewhat brittle or casted components, but in this case worm is usually made of steel, which is a driving member, and whereas worm gear is made of either bronze or cast iron. Usually it increases the cost of worm gear drive. So again, before moving to design of gears, a worm gear, we'll try to understand it has a high speed detection, compact gear drive, its operation is very smooth, and most important, self-locking operation can be obtained for a worm gear. Next one, there are some advantages. Very low efficiency due to the high speed or velocity ratio. Second case, since the worm gear is made of bronze or cast iron, which increases the cost of that material drive. Next, since when we compare spur gear or helical gear, power transmission is most probably with the help of tangential force or tangential drive, but in this case, that is in worm gear, power transmission is due to friction as well. So addition of tangential force with that friction, that is sliding motion is there, that's why transmission of power is there, and due to friction we know that heat generation takes place. So worm gear drive has a drawback of heat generation. Second case is it cannot transmit maximum power, so it is used for low power transmission. Now again, further we should understand types of worm gear drives. So usually worms initially is classified into two types. First one is cylindrical or we can call it as a straight. See, this one is the worm gear which is a cylindrical pattern, or we can say that it is a straight worm, it doesn't have any conical shape. Same case, next one is cone type, that is this worm which is a conical or enveloping type. So basic two types are there. For simple power transmission we can go for this, or for special purpose we have to go for conical drives. Next one, about the application of worm gear drives. Since there is a large speed reduction, slow motions can be obtained, so its application will be gate control mechanisms. Second one may be the hoisting mechanisms. Sometimes it is used for automobile steering mechanisms. Then hoisting mechanisms may be lift, conveyors, presses, and speed reducer as well. Next, so types of worm gears now, since we are aware about. So next one is types of worm gears. In that usually we have three types. First one is the face of the worm gear is straight one, so we call it as a straight worm gear. Second one we can call it as a hobbing type, that is sometimes it may be called as a conical face. And third one is the concave face which connects at a point over here. So usually we have three types of worm gears. Next one, actually this is the terminology of worm gears. Before understanding the design and the force analysis, first we should understand the terminologies. This is taken from Khurmi-Gupta book. So this figure shows a drive where this is a worm gear and this is a worm. So in this, first one is to be understood, that is diameter, outer and inner diameter. Next one, addendum and dedendum of worm. Then pressure angle, axial pitch. Next one is lead. Similarly, center distance. Likewise, for worm gear, diameter, teeth and outer diameter. Likewise, for a worm, helix is to be understood and its angle, then pressure angle, then lead. Next one, this diagram indicate or which will be specifically used for understanding the start of squares. So we'll discuss it in further sessions. Again, before moving further, some relationship is provided for using the lead and pressure angles. So whenever lead angle is in between this range 0 to 16, for that pressure angle should be in 14.5. So for 20-degree pressure angle, the lead angle should be in this range. Likewise, the table is continued. So this will be the standard values can be used. And second case is about velocity ratio. So start of threads depends on the velocity ratio. That is 36 and above we have single start thread, 12 to 36 we have double start thread, and it continues. So this is again from Khurmi-Gupta. Same thing, but before starting with the force analysis, we should understand these three angles. That is, gamma will be the notation specifically used in further sessions as a lead angle, helix angle psi, and pressure angle alpha. So that's all for today's session. In next session we'll continue with the force analysis. Thank you.